Alright, we're going to do some solving of linear equations. So we've already done some solving this year, so we're going to just build on that. I'll do a quick refresh, but then we're going to integrate some of our linear relations concepts like x-intercepts, y-intercepts, those types of things into these problems. So let's get solving. So we've done this type of problem before where we have x plus 5 equals -2. Some people can just intuitively know the answer. That's great, but there will always be problems where they get too big for your brain to handle and you'll need to have a strategy. So in this case, I want to get the x box all by itself, which means I want to get rid of these 5 positive ones. So I am going to introduce 5 negative ones on both sides. So I want to make sure that I keep everything fair and equal. What that looks like when I go to do the algebra to the left here is that I am going to subtract 5 from both sides. Now over here in the pictures, this piece right here all zeroes out. So that's all cancelled, and you'll notice on the right hand side I now have -7. So when I come back to my algebra, these two here would cancel just like I had the zero pair, and I'm left with x equals -7. Let's try our next one. 2x plus 1 equals 7. So I have two unknowns. They're both the same quantity. There's just two variables that way I have to keep track of. I have 7 ones on one side, one positive one on the other. So I need to bring down or subtract 1 from both sides. So I'm making sure I'm keeping that fair and equal. So let's go back to the algebra, and we will subtract 1 from both sides. This one and this one will zero out, just like this one and this one will zero out. So those are now gone. My algebra looks like this: 2x equals 6. Now if I want to figure out what two of these boxes are worth in terms of what each is in each box, I'm going to separate them into two equal groups, which is the act we call division. And it looks like this visually. Something like that. And then I'll see if I can get this guy out of here so he's not in the way. And now you can see, for this to be a true statement, or for this equation to be equal, I have to have exactly 3 in each box of x. So to do that from an algebra side, I would come over here and I would divide both sides by 2. And I would end up with x equals 3, which is what our picture over here says. Solving equations. So to cancel or eliminate an operation, something like add, subtract, divide, multiply, in an equation we can use the opposite operations. And this is really important. We're using the opposites to undo operations. Okay, so the opposite of adding is subtracting. The opposite of multiplying is dividing. The goal in all of this is to isolate the variable. So the goal of solving an equation is to get the unknown or variable isolated. Oops, that's the wrong one. I wanted to use a highlighter there. Let's try that again. So I want to isolate. That's a really important word. There we are. And isolated means in the top location, the numerator location, with a 1 as the coefficient. That's the number out front. In the past we have used SAMDEB as a guide, and we can continue to do that, but we have to remember it isn't a rule, it's just a guide. So let's try this as a one-step type of a question. So x divided by 2, I just got to get back into my pen here. So x divided by 2 equals 12. So what is the opposite of dividing by 2? Well, multiplying both sides by 2. And please notice where I write that, I'm writing it in the top, the numerator location, because 2 divided by 2 on the left side, these will actually cancel. Okay, and then I'm left with x equals 12 times 2, which is 24. And if I wanted to do a quick check, and I won't do this for all of them, but I can, I would put the 24 in for the x, I would divide it by 2, and I should get the original right side of 12. And I do. So if we want to solve x divided by 2 plus 3 equals 11, okay, it's a little trickier, so I'm still going to use my SAMDEB as a guide, just a guide. So what we notice first is that subtraction and addition is the first operations we want to go after. So in this case there's a plus 3. So I'm going to subtract 3. I want to use the opposite operation to undo. Those would cancel. And then my new equation looks like this. X divided by 2 equals 11 minus 3 is 8. Now if I want to solve or get the x totally by itself, I need to undo or get rid of this dividing by 2. And we've already seen that if we multiply by 2 on both sides, these 2's would cancel, and I would be left with x equals 16. And you can check that if you like. I'll leave that to you. A little bit trickier. This one has both numbers in the top and the bottom on the left hand side. So I'm going to go after the dividing by 5 first. So I'm going to multiply both sides by 5. These would cancel. I would be left with 3x equals, now 5 times 12 is going to be 60. And now I want to undo a multiplying by 3. So the opposite of multiplying by 3 is divide by 3. And when I do that division, I end up with x equals 20. Let's try one more. Ooh, this one's scary looking. Okay, so we have 3x divided by 2 plus 4. So again, I'm still going to use SAMDEB, even though it looks a bit scary. Make sure I spell it right over here. So I'm going after addition and subtraction first. So there's an adding of 4, so the opposite would be subtract 4. So I subtract 4 from both sides. And you'll notice I like to keep my fractions with a very clean top and bottom. 16 minus 4 is 12 on the right hand side. And now I have both a multiplication and a division to do. So I'm going to go after the dividing by 2. I'm going to multiply both sides by 2. Those will cancel. And now I'm left with 3x equals 24. And now I have to undo a multiplying by 3. And that leaves me with, and I'm going to go over here before I run out of room, x equals 8. And there's your answer. Let's try something a little bit more connected to our linear relations. I've already graphed this relation for you, so I have my table of values, I've drawn the picture, we can see it's linear, so we're not going to spend any time proving that. The first part says state the y-intercept and the slope for the above relation. So my y-intercept I know comes when my x equals 0, so my y-intercept is 0, negative 1, and it's that location right there. My slope I could get from either the picture, I could look at my rise and my run. So my slope would be 2 over 1, or I can check over here on my table of values and I can see how these are changing. This is going up by 2, this is going up by 1, or this is my rise, this is my run, and I can get my slope that way. Determine the equation of this, the equation that represents this relationship. Now hopefully we're starting to see that the equation involves both the slope or the multiplier and the y-intercept. So this equation would be y equals 2x minus 1. Okay, so we're now going to use the equation to determine the y value when x equals 24. Okay, so I want to determine the y value when x equals 24, so I'm going to take this x value and I'm going to substitute it in. So y equals 2 times 24 minus 1. Now if I do that calculation, I've got 2 times 24 is 48 minus 1. The answer would be 47. Now that 47 is only for when x equals 24. Okay, and lastly, determine the x-intercept for this relationship. So that's when y equals 0. That's one of those facts we have to know. All x-intercepts have a y value of 0. So if we use our equation, instead of putting y equals 2x minus 1, I can put 0 equals 2x minus 1, because I know that the y value is 0 for the point I'm looking for. Now from here I need to get the x by itself, so I'm going to add 1 to both sides. So I now have 1 equals 2x. I'm then going to divide both sides by 2, and I can come up with x equals 1/2. And as a coordinate, that would be 1/2, comma 0, and that would be my x-intercept. Okay, last question. Janice tracked her earnings for babysitting in the table below. So we have this table on the side here that has some of Janice's earnings. So we would need to determine the equation that represents Janice's earnings. So the first thing I would probably want to look at is, how is this changing? Okay, so I can see from 13 to 18, that's an increase of $5, $5, $5. Make sure I got enough there, and $5. So I have a constant first difference. All of these are changing by ones. So I have a pretty good idea that this is a linear relationship. I could plot this if I needed to, and I'll do that really quickly. So 1 and 13 is somewhere around there. 2 and 18, somewhere around there. And 3, 23. Now I set all this up in advance, of course, just for the interest of speed. 4 and 28, and 5 and 33. And we should see that looks like a pretty nice linear relationship. Let's see if I can draw a decent straight line here. Something like that. Okay, now there's something missing though. I can see I have a y-intercept here, and it looks like it's about 8. But my graph isn't always the most reliable tool, so I might want to go back to my table of values. And if I look at this, I had to start at something, increase by 5, and land at 13. Well, the only thing that could be is 8. And if I follow the pattern on the other side, I would have a 0 in the hours column. So I now have my y-intercept, which is really important, and I also have my slope. So if I take those two pieces of information, I can now write my equation. So my equation here, and I'm going to write it with some symbols that hopefully help make it easier to understand. So the amount of money she makes is going to be 5 times the number of hours plus 8. Okay, and now that's a partial relationship. We can tell because it didn't go through the origin. And now I have an equation to work with. Okay, that usually makes things a little bit quicker. Just going to give myself a little bit more room here to work. Janice has been asked to work a whole weekend, which would be 16.5 hours of babysitting. How much would she make? Well, this 16.5 hours, this is a unit of time. So that's going to go in for our h. So I can take my equation, 5, and instead of putting in an h there, I can replace it with 16.5. and plus 8. Okay, now if you're super comfortable, you might do that in your head. This is also a good time if you want to break out your calculator. Either way, we should come up with 90.50. Now I've included an extra decimal place here because we're talking about money. So she makes $90.50 for her babysitting on this weekend. Okay, and then the last part, Janice wants to make an even $50 for an extra word in there, for one night of babysitting. How many hours does she need to work? Okay, now we're asked for hours, so that means we're looking to find an h. Okay, and this guy right here, this is the amount of money we're using. So if we take our equation, and instead of the dollar sign there, I'm going to put in 50. So the 50 goes in here. And now I just have to solve this equation, which is what we were doing earlier, both in the year and today. So I'm going to use my SAMDEV guide. I'm going to subtract 8 from both sides. I may have to shoot over here so I can actually finish the question. Okay, and then I want to get the h by itself, so I divide both sides by 5. So I would have 42 over 5 equals h. And yes, you can have fraction answers. That's totally acceptable. If you're uncomfortable with that, you could do the division, and you could come up with 8.4 hours would be how many hours she'd have to work to make an even $50. Okay, there's a couple questions to try. Page 210, 212, and thank you for watching.